An LLM agent is an AI system that can autonomously plan and execute tasks by combining language model capabilities with tool usage, memory retention, and structured decision-making processes. Compared to RAG, Agent excels at creating query routes and planning workflows, with the following benefits: maintaining memory and state of previous model-generated responses, leveraging various tools based on specific criteria. This tool-using capability sets agents apart from basic RAG systems by giving the LLM independent control over tool selection. Breaking down a complex task into smaller steps and planning for a sequence of actions. Collaborating with other agents to form an orchestrated system. React Framework, introduced by Google Research paper Synergizing Reasoning and Acting in Language Models in 2022, is widely cited as the first formalization of LLM agent. React is composed of three elements: actions, thoughts, and observations, built upon chain of thought by integrating the reasoning steps with an action space that enables tool uses and function calling. Additionally, React Framework emphasizes on determining the next best action based on the environmental observations. As the result, React-based agents overcome prevalent issues of hallucination and error propagation as more often observed in chain-of-thought reasoning by interacting with external tools. Furthermore, through the implementation of decision traces, this approach additionally increases the interpretability, trustworthiness, and diagnosability of the agentic system. The code snippet below demonstrates a React-based agent implementation using Llama Index. Firstly, it defines two functions, multiply and add. Secondly, these two functions are encapsulated as function tool, forming the agent's action space and executed based on its reasoning. The advantages of LLM agents are more substantial when combined with self-reflection or self-correction. It is an increasingly growing domain with a variety of agent architecture being explored. For instance, Reflection Framework facilitates iterative learning by providing a summary of verbal feedback from environmental and storing the feedback in model's memory. Critic Framework empowers frozen LLMs to self-verify through interacting with external tools such as code interpreter and API calls. Check out our video for more details about fine-tuning and other LLM customization strategies.